What I'd like to do now is go ahead and do sort of a brief explanation of the Existics equations, where they come from, without having to get into too heavy of a conversation about the postulates and axioms from which the equations were derived. So, without further ado, when I was around sometime in my late teens, I can't remember if it was when I was 16 or 18, we had taken a family trip out to visit relatives, and I spent an afternoon with my great-grandmother. While we were hanging out, we had a conversation about, as you get older, does time go by faster? And I asked her, I said, at the time, I had noticed that, when you're 5, a week seems like an eternity, especially the week before your, 6th birthday, versus, when you're 18 years old, time doesn't seem to lag as much. So the question I was posing to my great-grandmother was whether or not in her mid-90s, did time continue to move faster? Did the experience of the rate of the passage of time continue to increase with age? And what she told me was that time went by so fast for her in her late 90s that she could almost watch the grass grow, which I found quite stunning, because the first thing I picture is one of those sped-up films, high-speed shutter films, where or not high-speed shutter, but basically a time-lapse photography where they show grass growing. So when she said this, something struck me that literally took me all of that summer to get out of my mind, and that was this question. When my great-grandmother and I were having this conversation, presuming that time does go by faster as we get older, since she was in her mid-90s and I'm in my late teens, clearly time is going by faster for her than it was for me. So here was the dilemma. For some given length of time, let's say a 1-hour conversation, okay, we have this 1-hour conversation, and the question is, if we have someone over here who's observing this conversation, and we've got another person over here who's observing this conversation, and time relative to this individual takes longer to pass than it does for this individual. Let's go ahead and make this the teenager, and this will be the grandparent. So, and let's just go ahead and pick some arbitrary numbers to make the mathematics a little bit more easy. Let's say my great-grandmother was 100 years old. And let's say I was 20 years old. So, what the issue is if we're having a 1-hour conversation between two individuals whose experience of the passage of time is different, how do we account for the conversation? Because it would seem or appear that the older person, given that time moves by faster as we age, assuming that to be true, the older person would be further along the conversation than the younger person, which is strange because, okay, so does that mean, how do we deal with the hour conversation? And what at the time seemed, and I still believe was a major breakthrough, is that in reality, what we have going on is that there are actually two conversations. There's one conversation relative to the younger person, and then there's one conversation relative to the older person, and basically what we have is there's a variance in time between the teenager and the grandparent as to where they are along the conversation. And using the value 120, let's just go ahead and assume for convenience that as we get older, time goes by faster, and that the curve that would follow would be the same for every individual, for simplicity. So we'll go ahead and let's find a ratio between the grandparent and the teenager of what time is from one relative to the other. So if we just take 100, put it over 20, we get the ratio 5, or if we put 20 over 100, we get the ratio 0.2. So basically what could be argued is that when the grandparent has completely gone through the 1 hour conversation, the teenager is at 0.2 hours into the conversation. So we could go ahead and say that, you know, since this one will be the conversation relative to the younger person is about, you know, about 0.2 hours into the conversation when the grandparent has actually completed the conversation, or when the younger person has completed this conversation, the grandparent is 5 hours into the future. So this is sort of the basic breakthrough from which all of the Existics equations arrives. And what we're now going to get into is the very interesting aspects of the further implications of there being two relative conversations, one relative to the older person and one relative to the younger. And ultimately what Existics is given this variance, how do we calculate where the younger person is in time relative to the older person and vice versa? And for those familiar with general and special relativity, you'll see that if there's any place in physics where this concept is going to plug in, it's definitely going to be in special relativity, dealing with variance in time. So, moving right along, the other place where this applies in physics, which is not as intuitive, but the impact is quite severe, that is on the concept of acceleration. But that's we'll get ourselves there. So basically, what you're looking at is the base concept for how Existics is going to come into play in physics in both special and general relativity and Newtonian mechanics, dealing with our basic definition of what acceleration is. What we've derived so far is that, assuming that as the experience of time progresses, as an analogy, just to get the mathematics worked out, we already have a basic ratio to work from. Let's go ahead and let the older person, they're going to be A, and the younger person is going to be B. And so far what we have is to solve for time, to solve for the time of the older person relative to the younger person. A over B equals N, where N is the experience of time of the older person relative to the younger. And then B over A will give us the experience of the younger person relative to the older person. So in our previous example, this equaled 5, and this equaled 0.2. So basically, 5 minutes to the older person is 1 minute to the younger person, or 0.2 minutes to the younger person is 1 minute to the younger. Minutes, days, hours, it really doesn't matter. This applies to whatever units you're working within, and obviously there has to be calibration and tinkering with this so that the equation, this general equation, would apply to specific situations where the variance in time may have variables that have to be applied to it to get a more accurate relative time to get a better understanding of relative time between these two observers who are experiencing two different rates of time. So what I'd like to point out here, before we get too much further, is that this concept that we're getting into is not found in special relativity. And in fact, special relativity specifically assumes this not to be the case. It's not expressed. When you go through the axioms or the postulates rather of special relativity, you won't find an expression that this is not the case, but it's assumed in how the equations are worked out. And when you look at the twin paradox, which we will go to at some point, that is where this false assumption really reveals itself, and then we apply the existics equations to the Lorentz transformation and ultimately calibrate it. And the essay I did that in is called the adjusted twin paradox, and again, that essay predicted in 2003 the phenomena we're now seeing with these superluminal neutrinos coming out of CERN. Okay, so putting that aside, another fundamental issue that arises here is the concept of absolute space. Now, it doesn't seem so intuitive, but basically, going back to the previous, go ahead and erase this, I guess. Going back to our example, when we were starting out, we had a single conversation. That was taken an hour long. Okay. What this serves as an analogy to is the concept of absolute space. We could think of this 1 hour conversation sort of a reference frame, whereby on this side of the reference frame, we have the teenager, and on this side of the reference frame, we have the great-grandmother. And this issue got argued back and forth between Isaac Newton and Gottfried Leibniz, if I'm pronouncing that correctly. And it has to do with the issue of whether or not there's an absolute space backdrop upon which the motions of physics can be measured against. And Newton's argument for the day won, and physics is carried along with this concept of absolute space. What's ironic is even though quantum mechanics and general relativity in a lot of ways abandon the concept of absolute space, it still is inherent to the assumptions of the calculus that's used in physics. So the irony is even though the concept may not still be part of the mainstream physics model, the assumptions that come from it still are. And this is actually a major handicap in physics, and we're going to see real quickly that pretty much most of the issues that are coming up today, or have for the last decade, really come from the fact that there are bad assumptions in the calculus that need a slight modification, adjustment, and once that's done, these apparent anomalies literally vanish. So what the Existics model would suggest is that in fact, we have two frames of reference, two distinct frames of reference. One relative to the younger person, and one relative to the older person. So this would be, if this is B and this is A, this would be the objective. This would be the objective frame of reference of A, and this would be the objective frame of reference of B. And notice that they are mutually exclusive, such that the clock over here for A can run 5 times faster than the clock over here for B, or the clock over here for B is running 0.2 times slower than the clock over here for A. So basically, if we had a split screen and we're filming an older person talking with a younger person, this side of the screen would be running slower than this side of the screen. So what the Existics equations are is, where is B in its frame of reference of time relative to A in its frame of reference of time, and vice versa. Now, something I don't want to get too severe into at this point, but I do have to mention, and that is part of the Existics model, is that in fact, not only is there an objective frame of reference that has to be accounted for, but in order to properly deal with this split reality, these mutually exclusive frames of reference, is that that A also has to have a subjective frame of reference, and that B as well has to have a subjective frame of reference. Now, what do I mean by subjective and objective? What is the distinction that I'm making here? Basically, what I'm getting at is ultimately I'm separating reality into two distinct fundamental attributes. And those are going to be physical. So there's physical attributes of things that exist, and non-physical attributes, things that exist. I already have uploaded about 8-10-minute videos that really cover this subject in depth. I really don't want to get caught up in this because I want to move forward into the more advanced aspects of the mathematics. But please feel free to go to Existics101.com, watch the videos, Existics 101, postulates, and I think the other is, I don't recall off the top of my head. I apologize that in the videos they progressively, me and the chalkboard and everything, turn green. It's a rendering issue. I'm going to replace these videos as soon as I kind of get past this little hurdle I'm at with a time crunch that I've imposed upon myself with the Wince versus Susskind challenge that I put out, that basically March 19th I need to have prepared, so I'm focusing on that. But, not to digress, going back to this, what you could think of as physical attributes is like the firmness aspects of my body, or matter. The non-physical aspects of me you could think of as my mind, feelings, thoughts. And we could debate all day as, what's physical, what isn't. Obviously, things that are physical also have properties that are non-physical, and things that are non-physical also seem to have properties that are physical. And it's almost an inescapable reality that no matter whether we call something physical or non-physical, you will always be able to find the opposite property somewhere within it. Again, this is all covered in the Existics 101 lectures. But for our purposes, what I'm basically doing is I'm making a coordinate system between physicality and non-physicality so that I could more or less just have non-physical frame of reference as an arbitrary dimensionality to attach to physical reality. And the reason why is that I'm replacing the concept of absolute space with relative space. We are now revisiting the Gottfried Leibniz model of the universe, which is based on interaction versus there being some backdrop from which all of the interactions of the universe derive back forward from. So that being said, the subjective frame of reference is more non-physical. The objective frame of reference is more physical. And that's basically it. So here's sort of the little backdrop for how we're going to start modeling out these reference frames in relation to one another, so that I can, in a sort of makeshift way real quickly kind of show you how the mathematics was derived. Because the problem is the Existics equations are so elegantly simple that how and why I'm using them has to be understood. Otherwise it just looks, it's just, what's this guy doing this weird little calculation for, and why does he think this is significant? Well, there's depth and complexity to how these simple equations were derived, and so we kind of have to briefly kind of cover that a little bit. Okay, so going back to our different frames of reference, let's go ahead and, this is B relative to B. When I put the brackets around the variable and then put it on the right-hand side to distinguish this from the way symbols are used to describe a function, this is simply stating B relative to B. And then over here, again, this would just be A relative to A. So this is A relative to A, and this is B relative to B. What's interesting is that if you really get into the axioms of existics and the reference frame schemata and how it's derived, it became quite apparent to me that in order for all of this to work, I actually have to have another great grandma, and I actually have to have another teenage boy. And what this ends up being is A relative to B, and this is B relative to A. So in order for there to be two conversations separate from one another, there has to be, even though A experiences time at a faster rate, there has to be an A relative to B such that B's talking to that A while A relative to themselves is just moving right along into their faster frame of reference, and vice versa. There has to be a B relative to A in the frame of reference of A such that as A's rolling right along into the future, there's a B rolling along right with them. So this is another contribution to physics, is that now all of a sudden, in order for two things to interact, we've got four things. But as you can see, obviously it's already implied there's going to be a subjective frame of reference and an objective frame of reference relative to the A, relative to the B, vice versa, etc. So what we really end up with here, in order to fully capture what's going on here and completely remove the concept of absolute space and replace it with a reference, infinite progression or regression of relative frames of reference interlaced with one another, this has got to go to infinity. So what we end up with is there's B, there's A relative to I'm sorry, there's B, there's B relative to B, there's A relative to A relative to B relative to A, but all this ad infinitum within here, sort of like when you hold up mirrors together like this and you get that endless reflection back and forth, you could kind of see that one mirror would be A, the other mirror is B, and the reflections going back and forth in between the two is A relative to B relative to A relative to B relative to A, that relative to A, and that relative to B. So we end up with something looking something like this: B relative to A relative to B relative to A, so on. A relative to B relative to A, so on. And so the question is, okay, now we've got these infinite frames of reference that are completely integrated into one another. How do we start pulling them apart to fleece out some kind of mathematics that we can then go back to special and general relativity and revisit Newtonian mechanics, the concept of acceleration, and see if we can apply it and get something?